Crash Pod days. All right, so chapter 10, game theory. So we're going to be delving into more of the nitty gritty, more of the, before we kind of learned the undergrad version of game theory. And so now we're going to be kind of taking it to that graduate level, right? So the first thing that we have to remember in terms of game theory is that the order of decisions is important, right? Sorry, very important person, let's just say. So we have been talking up until this point about simultaneous move games, right? So what is happening in a simultaneous move game? So what's the example? Our Bertrand duopoly game, right? And so what are the characteristics of this simultaneous move game? Each player makes decisions without the knowledge of the other player's decision. So, are they aware of the payoffs for the other player? Think about it. What was going on in our Bertrand duopoly game? So, let's look back to chapter. Well, I guess we only really talked about the Sweezy. We got to back up a little ways, don't we? So, before we jump further into chapter 10, let's back up so we know what the heck I'm talking about here. All right.
Okay.
So, however, so this actually ties back. So we'll jump back to chapter 9 in a second here. But before that, so we just finished the Squeezy game, right? That was the first one that we talked about. Corno. We talked about the Corno, which is the same as the Squeezy, right? And then the next kind is a sequential move game, which is what we're going to talk about in class today. So sequential move game. And so what is this? It's just like it sounds. One player makes a move after observing the other player's move. Very good. E2. So I'm not going to test you guys on the curves for the Corno oligopoly, just the math. Okay? So don't worry about the curves with the profit curves and stuff. Okay. Seems unnecessarily complicated. Okay. So let's get back up. Chapter 9. And we're going to just talk about the Stackelberg oligopoly. So they talk about this on page 284 of the text. Stackelberg oligopoly, what are the characteristics of it, right? We're going to have few firms, sorry, many consumers. You know, could be differentiated or, don't really care, homogeneous products. What do I mean by homogeneous compared to heterogeneous? So heterogeneous would be the differentiated part, right? So hetero means different or mixed. Homo means the same, right? Homogenization with milk, it's to get all the milk the same, I'm assuming. So homogeneous is it's all standardized, right? So, you know, when you go and buy what's like a super homogeneous product? An apple, right? Like a red delicious apple. You know, are you really going to be like looking at, you know, the characteristics of the producer of the apple or something like that? Are you just going to get the cheapest apple? You know, like there might be organic versus non-organic, right? But even then, like, do you care between one organic apple and another organic apple? Like, not really. They're very homogeneous, right? As opposed to what's a differentiated product that we might see in something like this. Juice, yes, exactly, very good. So, but in the Stackelberg oligopoly, right, this is a sequential move game, right? So one player makes a move after observing the other player, okay? So that move is going to be made by a single firm, okay? We call it a leader. They go first, choosing Q1 before, you know, all the other allocations, Q2, Q3, Q4 are decided. So don't get these confused by different quarters. I'm just talking about different firms, right? For the most part, we're only going to be, I mean, not for the most part, for all of this class, we're only going to be talking about two, right? Just one player and another player. But all of this can be generalized to n players, right? So just keep that in mind. And then all the other firms, right? So if we have a single firm that's going first, right, then all other firms, we call them the followers. Yeah, very original nomenclature here. They take Q1 as given and choose outputs to maximize their own profit. Does that make sense, everybody? And then the last characteristic of our Stackelberg oligopoly, right? This is the characteristic of all oligopolies. Could you and I just go out and start a cable company tomorrow? No, right? There are barriers to entry. Okay, cool. So let's get into the math of it. I know what you've been waiting for. If I would have been able to like do mathematical proofs a little bit better, I'd probably be teaching calculus right now. I'd be just as happy. Okay, so what's the equilibrium output formulae? Every time I read formulae, I think about like grosses me out. So we are going to have a linear demand function, just to kind of make things simpler, right? It's not going to be linear in real life. You know, the econometric estimation is almost always non-linear for these things. But whatever, we're going to just assume they're linear, okay? So it's going to look very familiar. It's going to be P equals A minus B Q1 plus Q2, right? Just like what we had with the formula. Okay. Is this an inverse demand function or a regular demand function? It's inverse. Why is it inverse? It's inverse because it's talking about price in terms of quantity, right? Is that actually what happens? Is it, you know, so for the most part, right, we make decisions on whether to purchase something based on the price, right? So that's why most demand equations are quantity demanded is equal to some function of price. Does that make sense? And so that's why this, when it's price as a function of quantity, this is inverse, and this is just regular demand. Okay? Just kind of a small thing. No, they're always negative, downward sloping, buddy. So that's the weird thing about demand as well, right? In terms of, so here, let's go ahead and let's assume. What are you saying? That's good. That's good. Did you All right. So like real quick, like if we have, so what would this be if we had price and quantity, right? It would be P minus, so we know that A is greater than 0 and B is greater than 0, right? And so this is going to be quantity total, right? Because that's what it's given. And so this is going to be a downward sloping line, right? Where the intercept is A and the slope is negative B, right? Now let's go ahead and manipulate this around. What if, so let's go ahead and say this is equal to QT. Then we've got P equals A minus B QT. Then we've got P minus A equals negative B times QT. Divide everything by negative B, divide everything by negative B. We end up with A over B minus 1 over B times P equal to QT. And so since B is greater than 0, right? B greater than 0, therefore negative 1 over B is less than 0. So if we were to graph out the regular demand curve in terms of quantity as a function of price, then it's also going to be downward sloping with a slope of negative 1 over B and a intercept of A over B. So it doesn't matter which way you slice it, it's always downward sloping. Part of a mnemonic, right? Demand starts with D, downward starts with D, and it's always downward sloping. All right, so back to our Stackelberg oligopoly, right? So we are given this general form. We're given cost functions. I don't know why I made that I. It's Q1. C1 is equal to C1, Q1, and then C2. Q2 is equal to C2, Q2. Okay? So the leader's output. So the leader's output is going to be given by the following format, right? So Q1 is equal to, so this is the non-calculus way. Give it to you. This is Stackelberg. Yes. So that's when there's a leader that goes first and everybody else follows. So you can think about this as like Walmart. You know, Walmart is going to go first and everybody else is going to react. So it's Walmart. You know, so Target and Amazon, you know, a lot of their pricing schemas are a result of the existing supply of goods that Walmart has on the price. So it's going to be A plus C2 minus 2C1 all over 2B. So this is our algebraic shortcut for figuring out leader 1's output. I will record a longer video and put it online for the 3 of you that care for the calculus solution to it. But we don't have enough class time. So this is what most of you care about. All right, and then what is Q2 going to do, right? So Q1 is going to produce according to that formula, and then Q2, remember that Q2 is the only one that actually has a reaction function here, right? Because Q1, it just does whatever the heck it wants, first, right? You know, it doesn't know what's going on with Q2, doesn't really care. We can see that by the fact that there's no Q2 present in this. Is that open door distracted? Should we close it? There are cute boys out there. I wish. All right, and so this one's going to be A minus C2 over B2, or sorry, over 2B minus 1/2 times Q1. So, you know, they know what Q1 is because, so why do they know what Q1 is? They know what Q1 is because they know what their own costs are. You know, they have a good approximation of what the other person's costs are. And, you know, they know what B is, right? Because B is given by the market demand function. You know, that they've run some econometric estimations, or they've used other people's econometric estimations to figure out, like, how does the price react to a change in the quantity of this particular good, right? Of Michael Jordan exclusive shoes or something, right? To date myself, that was one of the things that was very, you know, rare and coveted, and, you know, price would skyrocket because of the rarity. You know what I mean? So let's go ahead and do a problem. Let's do what if we have, so stack over example. So what if we got P equals 50 minus Q1 plus Q2, and the firm's costs both have constant marginal cost of 2. So let's see here. We've got 3 tables. We'll all just work on it. What's firm 2's reaction function? So go ahead in the next minute or so. Figure out firm 2's reaction function. But it's just okay. So we have the reaction function here. We have the price. We have the inverse demand, right? What's A? 50. Very good. So how did you know that A was 50? Right. Right. Exactly. So we're just matching that doodle up with that doodle, right? Sweet. Okay. So then, what is B? Is it -1? I actually made this mistake myself. It's just positive, right? Yeah, because it's always negative, right? So B is going to be, so we'll say A equals 50, B equals +1. What is C1? 2. What's C2? 2. Okay. So now let's plug that in to this formula right here, right? This is Q2's reaction function. So we have C1. We don't even need C1. We have C2. We have A. We have B. We don't have Q1 yet, and that's okay, because why? It's a reaction function, right? So it's we're used to having it in terms of someone else's output. So, like I said, I made this mistake myself. So it's actually +2 down here. It's +24 -1. right? Because it's just 50 minus 2, 48, over positive 2. This is 2 times 1. B is 1. I know, it's a little annoying when there's not a constant there, but you just got, yeah. So just remember that. Remember the question. B, you know, it assumes B is negative because it's demand, right? It's always negative, you know, law of demand. As the price goes down, quantity increases. As quantity goes down, price increases. So I was told both have a constant marginal cost of 2. Yeah. So sometimes they're not going to just give you out that cost function, and they'll just tell it to you in the problem. So if it's a constant marginal cost, which all of these will be, there's not going to be one that doesn't have constant marginal cost. But this is odd that they're both 2. A lot of times they're different, right? What's that? The plus 2. Okay, so remember that our general equation here is P equals A minus B Q1 plus Q2, right? So if it's A minus B, then that means A is 50 and B is positive 1. And so then we're just applying this formula, right? So this is going to be A minus C2 over 2B minus 1/2 Q1. And so that's going to be 50 minus 2 over 2 times positive 1 minus 1/2 Q1. Does that make sense now? Okay, cool. All right, so the next part is what's firm one's output. What? This is finishing it. This is the reaction function. We don't know what Q1 is. We're going to figure that out. So that's the next. So this is segueing us into our next part of the question. That's fine. No, you're fine. You understand now? Okay, good. What is firm one's output, right? What is Q1? So go ahead and don't ruin it. We need a surprise for everyone, you know. Otherwise, they're not motivated. They're at the edge of their seats. All right, this is our formula for Q1. So go ahead. I will freeze the screen and solve it, and we will unfreeze in a minute. Who turns these off? Like, no. It reminds me of the great part of you guys see the Family Guy remake? Oh, I think it just died. The Family Guy remake of A New Hope, and they're in now a little scene, and they're trying to shoot at the space pod, and they're like, oh, there's no light craft in there because it was full of droids, and they're like, what, are we paying by the laser here? Like, who's turning this off? You know what I mean? Like, it's such a small. All right, this doesn't work. That is. Apparently, but let's walk through it. So Q1. So Q1 is equal to A minus C2 minus 2C1 over 2B. So it's going to be 50 minus, thank you, plus 2 minus 2 times 2. I'm going to do the steps out for people's over 2 times 1. So this is 48 over 2 is 24. She gets it. I'll put cookies for everybody. You like Oreos? No? What is a good cookie then? Donuts? I'll bring donut holes in. Not made of money here. Bring donut holes in. Mint Oreos are terrible, yes. Most mint things are bad because they have almond flavor in it. I don't know why. Anyways, back on topic. What's firm 2's output? So now we got to take this 24 and we got to plug it back into our reaction function, right? So Q2 is equal to positive 24 minus 1/2 times 24. So it's going to be 12. Sorry. Okay, we're bringing donuts in. So now, what is the market price? How do we figure out the market price? Well, if we have Q1 and we have Q2, it's easy as P equals 50 minus Q1 plus Q2, right? So 12 plus 24 is 36. 14 agreements. Awesome. Questions on that? Cookie? Stuck on the cookie. Love it. Pizza. Okay. So the next part. So what's happening in this? Actually, no, we didn't move to the last type of oligopoly before any kind of discussion of Bertrand oligopoly. This is the last one. Well, but then we're going to talk about all these as sequential, and then you know, not repeated and infinitely repeated. So that's the last one, but we're going to be discussing it. I know. All right. So what are the characteristics of the Bertrand? Right. So we got few markets, or few firms. Sorry, few firms, many consumers. We've got identical products. Like an apple. We've got constant marginal cost, right? So how are the firms competing? They're engaging in price competition. What does that mean? They're reacting optimally to prices charged by competitors. What do I mean by optimally? In such a way to do what? Maximize profits. Exactly. All right. So, a couple of interesting assumptions here. Consumers have perfect information. What does that mean? Right. So essentially, you know, they're aware of the, you know, how it's produced, and they're aware of the kind of manipulation and the market power that all the companies are employing, and so on and so forth. Right. Right. Yeah. Yeah. Very good. And everybody knows that they use factories that have anti-suicide nets because there's been so many people jumping to their death in their factories because the labor conditions are terrible. They won't even let them kill themselves. Dude, I know exactly. I feel like that'd be a really interesting like experience. You know what I mean? Like, or like a tour guide or a field trip for middle schoolers. You know what I mean? Like, spend an hour working in this factory. All right, and then we've got what's the last part? We've got no transaction costs. So this is the most bullshit assumption of all. Even if there's no transaction costs, it takes time to do stuff. So time is, you know, a transaction cost, right? And the last one, of course, because it's a oligopoly, we've got barriers to entry. So when we are in equilibrium for a Bertrand oligopoly, what does that actually mean? What does that mean when we are in equilibrium? Bertrand equilibrium. So it implies that what the firms undercut to capture the entire profit or the entire market and leave rivals, in the cold with no profit. And what's going to happen as well? What are the consumers going to do? Consumers consume the low price. Yeah. Sorry. Slide to the left. You killed it there, man. Man, I haven't got a laugh like that in a long time. All right, so consumer slide. So elite rivals, no profit. And so in our equilibrium, right, we've got price 1 equal price 2 equal what? Marginal cost. So this is also known as the socially efficient quantity. Why is it socially efficient? Because there's more of the product being produced at a lower price, and so more people are enjoying the product. And essentially, the notion is that if we don't produce at P1 equals P2 equals marginal cost, then like we're kind of leaving extra production on the table. So there's enjoyment that consumers could be having. There's some people that could say the product is, say the apple is $2, but there are people that be willing to buy it for $1.50, right? And that's the socially efficient cost. And there would be 3 million apples consumed instead of 2.5 million apples consumed. So the kind of the notion of social efficiency is talking about getting the most to consumers at a lower price, right? And so it kind of ties into the production possibility frontier in terms of, are we actually producing on the edge, or are we producing at some point inside? Kind of hard stuff. Okay, so let's compare some oligopoly models, right? Kind of bring it all together for the last 15 minutes. So if we've got the following inverse demand function, right? We've got, that's regular demand. We've got P equals 1,000 minus Q1 plus Q2. And our cost function for each firm is identical. So we will say C of I for Q of I, right? So the I subscript is just going to be, so we can unpack this as C of 1 for Q of 1, or C of 2 for Q of 2, or C of 3 for Q of 3. Again, we're only going to be using 1 and 2, but it's generalizable. To use the math language is equal to 4 Q I, right? So this is the math way of the prompt I gave you earlier, which was all the firms have the same marginal cost of 2. Now it's all the firms have the same marginal cost of 2. So under these conditions, let's examine the different oligopoly output prices and profits, shall we? So if we had a Cournot oligopoly reaction function, right? Reaction function. What are they? So what would our Q1 be, and what would our Q2 be? So go back through your notes, find those formulae. Don't go through the calculus again, because that's going to take you some time, but just find the formula, unpack this in the formula, and provide me with the reaction functions in, let's say, 2 minutes. Freeze. You know what it is? There's 2 mouses here. Page 277. So from the bat, from just looking at the situation, are these two firms symmetrical? What does it mean by being symmetrical? Do they both face the same inverse demand function? Do they both have the same marginal cost? So how are they different? They're not. They're symmetrical. You were right, but it was not justified. So, if they're the same, do we have to do both calculations? No, we only need to do one, and then we just flip the Q's, right? So it's pretty nice. Thank you, Tom. So our formula, again, from page 277 in the text, right? That's where these are coming from, bottom of page 277. And we are just plugging and chugging, right? We're labeling A is 1,000, B is equal to 1, C1 is 4, C2 is 4. We're plugging that in. We end up with 498 minus 1 half Q2 as the Q1 reaction function, and 498 minus 1 half Q1 as the Q2 reaction function. What's up? Okay, good. So, what's my equilibrium price? Go. Yeah, because it's the same. Yeah, so the I is just a subscript that's just general for any firms. And so they'll give this to you again. And it's because of the fact that all of these things, we solve them kind of in two dimensions right now with just two firms, but all of them can be expanded to include more than two firms. So that's why they're doing it. If I was writing the text, I would not give you guys the subscripts and just stick with 1 and 2, because I think it unnecessarily complicates things, but I'm not writing any textbooks right now. So, yeah. Right. Yes. So this is the determining factor for symmetrical for all of well, not for all of these, because the Stackelberg is not going to be symmetrical even if they have the same costs and stuff, right? Because one of them is the leader and they're going first, and the other one's making their decision based on that. So that's going to change their quantities. And then the last one, I believe. Well, no, the Bertrand one is usually symmetrical as well. So yeah, so you just have to worry about if the costs are the same, then the Cornell and the Bertrand are going to have they're going to be symmetrical, but the Stackelberg is never going to be symmetrical because there's that inequity in terms of some person has the privilege of going first. Does that make sense? So how do we get the price, right? Well, first we have to get the quantities. So in order to get the quantities, what are we going to do? We're going to plug one of these into the other one, right? So I took the Q1 equation and I plugged this. Sorry, this is supposed to be in terms of Q2 or in terms of. Wait, hold on. No. This is all equal to Q1. This is all. Crap, that's right. This is all equal to Q2. So I took the Q1 equation. I plugged this into that Q2. And that's where I got Q1 equals 498 minus 1 half, open brackets, 498 minus 1 half Q1. And so then I just expanded it and isolated Q1, and I ended up with 332. And because it's symmetrical, I could do the same thing, but I also know that this is going to be my Q2 star as well. of the time. So how do I find out the price? Well, from here it's actually relatively easy. We just go back to that initial formula that we were given, 1,000 minus, sorry, not minus B, minus Q1 plus Q2. So it ends up being 1,000 minus 664. So we end up with a price of 336. Questions on how to get there? So remember, the reaction function is just kind of the first part of the battle, right? And then you have to set them equal to each other or substitute one into the other, which I find easier. And then solve for the quantity. If they're symmetrical, that's the same quantity for the other one. Plug those into the price equation. And the last thing it usually asks is what? What are we caring about? What are they trying to, what are they deciding? Sorry, they're deciding their output to maximize what? Profits, right? So a lot of times they will ask you what is the resultant profit, right? Profit 1 is going to be equal to profit 2. It's going to be equal to the total revenue minus the total cost, right? So it's going to be the price times the quantity for a particular firm minus, and we can use I here for one, minus the cost, the total cost of that firm. So this is going to be 336 times 332 minus 4 times 332. Wait, so how am I getting that 4 times 332? This cost equation was given to me earlier as CI QI is equal to 4 QI. So this ends up being $110,224. Yeah, but it's also on. If you want to do it more. Okay, so now let's talk about the Stackelberg, right? So we're trying to compare all these models, right? That was the, which one? The Corno. It's the first one that we learned. So Corno. We might just want to say profit C, P star C, Q1 star C or something, right? Just to remind ourselves that's the Corno. Now let's go ahead and what is the Stackelberg leader and follower output? All right, so the Stackelberg leader, follower. So I'm always going to have the leader as Q1 and the follower as Q2. Just makes sense. We can also call them QL or Q leader, whatever. So we know that there is a handy-dandy equation given to us on page 286. Okay. So it's going to be Q1 is equal to A minus C2 plus C2. How many times? Plus. A plus C2 minus 2C1 over 2B. And so we go back to our prompt, the information that we were given, right? So it's going to be 1,000 plus 4 minus 8 over 2. So 996 divided by 2. All right, so that's our leader, right? 498. So now that we have that, we can plug that into our follower equation, our Corno reaction function. So remember, we only have one Corno reaction function, right? Q2 is equal to R of Q1 is equal to what? Let's switch up the colors. A minus C2 over 2B minus 1/2 Q1. So this is going to be 1,000 minus 4 over 2, so 498 minus 1/2 498. So this ends up being 240. And so a common trend to this stack-over situation is that the first firm is going to have more quantity than the second. So it's kind of a good litmus test. If you solve for Q1 and Q2, and Q2 is bigger than Q1, probably doesn't drag. All right, so we know from here it's relatively easy to finish up, right? Because we just used that price equation. Price is equal to 1,000 minus 498 plus 249. That ends up being 253. And then we go ahead and we calculate the profit. You know, we're gonna have to calculate it separately, right? So the profit for the leader is equal to the 253 times 498 minus what? 4 times 498. And the profit for the follower is going to be 253, so they have the same price, but they're going to be selling a lot less, 249 minus, they're paying the same marginal cost on all 253 of them. And so we end up getting a profit for the leader of $124,002 and a profit for the follower of $62,001, which makes sense, right? They're the leader. They're the ones that are, you know, the profit for leader. The follower right here. So it's, yeah, it's the 253 times the 249. So they both have the same price. And they sell fewer, exactly. And they have the same marginal cost, but they sell fewer. And so at the end of the day, you know, they're making almost twice the amount of money as the follower, right? Because of that. This is called first mover advantage. Yes, thank you. Because this is equal Q2, yes. All right, so last one, I'll have you guys do this on your own, and we will, you guys, I can meet on Friday. You guys don't usually like to meet on Friday. I'll just make a video about the math behind all this crap and put it on YouTube. Maybe give like an extra credit question or something for people that want to learn calculus. Okay? Because it is interesting, and I think it's easier to learn and understand rather than just memorizing a stupid formula. But then what I want you to do for class on Monday is what is the Bertrand price, quantity, and profit, okay? So we'll start with that first thing on Monday, the Bertrand price, quantity 1, quantity 2, and then each profit. Profit 1, profit 2. Awesome. There you go. Thanks. Okay, questions? I thought I did. Yeah, I thought I did. Yeah, I thought I did. So yeah, we're just going to go. I'll double check this after that. Probably do it for the others, but online class feels not fair. That's the one that will look when I'm cutting you guys loose. Honestly, chapter 10 is enough to keep us busy all next week. I like chapter 10. I'll send you some more stuff, man. Sorry about that. I'll send you some probability stuff. That's going to come. Is this easier, though? Okay. Yeah, if you beat me at anything, man. Anything. I know how to play pool for sure. All right, just send me an email, and I'm going to make sure to bring my cue in. Cue? Yeah, I got one. What? I got my own stick, man. You definitely put my button back. But I'd like to play pool too. I enjoy it. So yeah, we go to the student center, play video games, play games. Yeah, what time's practice? Yeah. Okay. Yeah. All right. Cool. I'll see you then. Where in the world